In this video, we're going to be talking about the memory stack of an application, specifically with Java. Some prerequisite knowledge you should have before watching this video is you should have some Java programming experience. I'm not going to explain every single thing about Java, and you should know a little bit more about primitive values than I'm going to get into the integers and longs, floats, doubles, and characters. We're only going to be using integers in this video, but you should know how to declare a value and manipulate that variable and the value within that variable. You should know about calling methods. You should know about how to pass values in the method parameters and how to manipulate those values. And you should also know about the return values of methods, the return types, and how to tell what type is being returned and things like that with methods. You should also have some experience with object-oriented programming before watching this. I'll be going more into constructors. Hopefully you know what a constructor is. If not, I'll go into it a little bit, but this video will hopefully make constructors a little bit more clear in this video. This video is part of two. The next video I'm going to show this code in action in the IDE, in Eclipse to be specific, and I'm going to show how to debug with the knowledge gained in this video about the memory stack. And so, but you should watch this one first before you get into the next one. I'm going to refer to this video quite a bit. So when talking about memory, we can sometimes think, it's something that is very technical and can be difficult to think about, but it is something that's very important in our software development and programming skills. And let me explain the why of why it's so important. Understanding it is what helps you understand other things, and so it helps you understand object-oriented programming. It really helps you understand the constructors and objects versus classes and how those objects are manipulated in memory. And it will also help you understand pass by value versus pass by reference. When will a variable be changed when I pass it through a method, things like that. Technically, just a quick note, technically Java does everything pass by value, but you'll see what I mean when I say pass by value versus pass by reference. Understanding it will also help you understand the programming language syntax better, in our case Java. The new and this keyword we'll kind of go over, and also static versus non-static methods. You'll really understand that what it means for a method to be static and non-static and why that's important. And it also will help you understand debugging. Understanding the memory stack and when you're debugging in the IDE will help you know how to better navigate and better understand what is happening when you're looking at it. Basically, you become a better programmer when you understand the memory stack. It's something that you should really know and strive to memorize throughout your whole career as a programmer and software developer. So this is the memory stack. This is something that if you Google, this is a similar image to what you'll see on Google Images for memory stack. When we're talking about memory, we're talking about RAM. So that very expensive piece of hardware that you spend hundreds of dollars on when you're upgrading your computer or buying a computer. When you have more RAM, you're able to have more applications run at the same time. And it's because when you have an application run, we'll start at the bottom here, all of the instructions or the code that you write or that was written for that program is loaded into memory. Everything else is also loaded into memory. These are literals and static data. That's things that you can access anywhere within your program code and the application. The literals are constants, so they have the final keyword in Java. Static data, so these are global variables. They use the static keyword, and this is static meaning referring to variables, not methods, but anytime the static keyword is used with a variable. So if you do like static int or static double, things like that. We'll spend most of our time talking about the heap and the stack. The heap is where objects are placed. It's whenever the new keyword is used in Java. And non-static objects that are placed are on the heap. And the stack is local variables. So if you were to just do int x equals 0, that is placed on the stack. The stack has something called a frame pointer, a stack frame pointer. You're going to have many frames. And you're only looking at one frame at a time when you're looking at the stack. Again, we'll get more into this, especially the stack and heap, but this is the memory model of the memory stack model of an application. This is our app. It's very small. It's a little bit contrived, but will do its purpose in kind of showing us some of these principles. We're dealing with just a point objects or a point class and manipulating data with the points and things like that. You can see that we have method names here that are very, very similar. I did that on purpose. It's to, one, prove a point about writing method names well. It's also practice for how to just read what a method is doing and the difference between static and non-static and things like that. And so that's why I kind of made them very similar to one another. And then here is our object. This is the point object code or the class code. And you can see that the app is referring to all of the methods within this point class here. And within our point class, so this is the constructor of the point object. This is where you define when a new point object is created, what you do with the data that is passed through. And these are the variables of a point. We're just doing an x and a y. And I think I mentioned, but maybe I didn't, but many of these methods are static, some of them are not, and we'll get into kind of the difference between those. So starting our application, we start right at main for a Java application. That's where we enter into our app. And we have int x equals 0. So this is where we place our data here in memory on the stack. We have the curly brackets here. That's also an indicator of a stack frame that we're in. We will get a new stack frame when we go into a new, either into a constructor or another method. And so you can see that we have our stack frame with x, and then we also add y equals 0. So this is where we're going to get into a new stack frame. We are creating, a lot of stuff is happening here. So one, we have the new keyword. So whenever the new keyword is used, I'm going to repeat this a lot in this video. Whenever the new keyword is used, an object will be created on the heap, and we will enter the constructor of that object. So we have this value p here. It's going to be on the stack and is a reference to the point object that we're going to create on the heap. So remember, we enter into the constructor whenever the new keyword is declared. When we enter into constructor, it's really like entering a method. The difference is that we're referring to an object on the heap, and this keyword is referring to the object that was just created on the heap. So we passed 0, 0 right here, And that is what is given here to these values in this stack frame, x and y 0, 0. It's not referring to these, the 0, 0 to this x and y up here. And then this is where we use the this keyword to refer to the point object just created on the heap to assign it the value that was right here. So this dot x is should have the same value as the x that was right here, and we do the same thing as the y. When we return, we have this again. We have this new object on the heap, and we have this point object p referring to that point object in the heap. This is not where the object data lies. The object data lies here. This p is just a reference to this p down here. So I hope you get that distinction. So when we go to the next line, a common mistake for early programmers is they think that they have to refer to a method within a class by declaring a new point p and then doing p dot. And that's actually what's happening down here. But right here, what you do is you just, if it's a static method, you just need to do point dot and then the method. You don't need to refer from an object that was created. You just need to do point dot and then the method. So when we enter into this method, we are passing the value 0, and a new stack frame is created, and this parameter is given the same value that was in x, but it is not referring to that same x. It is a brand new x. It just copied the value into this x on this new stack frame. So when we increment x, we increment this one right here. We do not increment the one that was declared in main. And again, because it's a static method, we could just do point dot increment x. We don't have to refer from p dot from a point that was created. It's just point dot increment x. If we were to print it out right here, it would be 1, and we return it. We're not doing with anything with that return value. But if we were to try to print out x right here, it would print out 0, would not print out 1. It's a different x. It's not the same x. So we're doing the same thing here with point dot increment y. We're creating a brand new y on the new stack frame, doing y++, and then system.out.println line would be 1. If we were to print out y at this point, it would not print out 1. It would print out 0. It's a different y. It's totally different when you're passing it by value right there. Again, as I pointed out, this increment point is a static method. It's not a non-static method. So this technically is wrong. The IDE will give you a warning. It will still compile and run, but you really should refer to this as just point dot increment point. And then when we pass the values 6 and 7 here, it's a new stack frame. We pass them. Now again, when the new keyword is called, what did I say that 2 things happen? 1, a new object is created on the heap, and 2, you enter the constructor. I'm not going to enter the constructor of the point right now, but just to know that we did enter the constructor and we did assign the values that are passed there, which would have been 6 and 7. With a new constructor, it would have been a brand new stack frame and everything. Now this is interesting. This is not, I shaded this purple because there's now no reference to this object. This object was created right here with this new keyword. But there is nothing now referring to that object. There's nothing in the statics or literals. There's nothing in the stack frame, and so that's why I marked it purple. There's no way that we at this point can now access this point that was created in this method right here. So now we're actually getting to something that's more object oriented with this p dot increment this point. And so we actually, because this is a method that is not static, we have to call it off of a point that was already created. So point dot increment this point. We're passing the value 3, and so that value is placed here. But we're now referring to this, and this is referring to the point P that it was called off of. Point P right here that was created, dot increment point. So that's why this is not static. We're able to now manipulate the object point right here using the this keyword, and that's what we do right there. X dot equals 3 now because of the 3 right here, and we'll do the same thing with y with the value 5. Again, it's non-static, so we're actually manipulating this point P here, and it has to be called by P dot. It cannot be called by point dot increment this point y. You would get an error, and it won't compile and run because it's saying what point am I referring to? What are you referring to? Because this is a non-static method, and we'll increment it there. This is another example of how this is a non-static method, increment point, and this is an example of overloading. What overloading is this has the same name as this method up here of increment point, but it has different parameters. When a method has the same name but different parameters, it's still a different method. The computer does not look at this as the same thing, even though they have the same name. This is static, and again, this would be wrong, and I'll fix it later in the next video and show you what I mean. But we are passing the point P here, and I'll show you. You might be like, well, I thought you said that if it's non-static, that's when you can manipulate the object, but when it's static, you can't do that. Well, we're passing the reference of point P here, which is a new stack frame, and it's pointing to this point here, and we're just manipulating the data of that point by accessing the object this way. So you can have non-static methods or means called within a static method, but ultimately I could not use this keyword right here. That would be invalid because it is a static method. And the only reason I am manipulating this point P is not because it's being called right there, but because it's being called right there. And so we go through and we add 2 to 3, and we're going to add 4 to 5, and that's what that increment point does there. And now we have this point PP equals P dot increment point, and so this is another static method that it would be proper to replace that P with point. Again, I did this to point out that this P, many programmers immediately think that they need to call methods with a instantiated or initialized object. That's not true. You can just call static methods by just calling point dot increment point. And if you remember what this increment point does from up here, it just returns a new point. Whenever the new keyword is called, we went into the constructor, it assigned those values, and it created the new point on the heap. And this is returning the point, and it's returning the reference, which this now PP refers to. It now refers to this point here. We then print out the data of those points, and this is just another view of our object. You can see that I hope you now understand the difference between having these static and non-static methods and what they do. Just kind of an overview, just a reminder of the memory stack. The most important thing is to really understand the heap and the stack. And when objects are created, classes can become objects if they're put on the heap, and objects are created when you use the new keyword and the constructor is accessed. But you can just access static class methods without instantiating an object. And then we talked about the stack versus heap and the new and this keywords and their importance, and also pass by value versus pass by reference, and a little bit of overloading. and what it means for two methods to have the same name but different parameters. And I hope you stick around for the next video. I'm going to show this code run on the IDE and how to debug it and what it looks like, especially with our knowledge of the memory stack, and also some fixes that we needed to make when it came to calling those class methods, those static methods.